Hey guys, welcome back to another video. It's me, Roland, your tutor from Think Brainwave. And in this video, we're going to continue with special angles examples. So far, if you haven't watched the previous couple of videos, we started off by explaining the trig identities in terms of special angles and explaining SOHCAHTOA and how hypotenuse is always opposite to the 90-degree angle. And then your opposite line is always opposite your angle in reference point. Then your alternative side is always dependent on your opposite. So these two change, the opposite and the alternative always change. But the main thing to realize is that the alternative is always the other line that no one really cares about unless you're doing cos. But I'll get more into that throughout this example. So in this case, we want to find x and y in the following right angle triangle. How do we know it's a right angle triangle? Well, it may seem easy enough to everybody that knows, but those that don't know, a right angle triangle is a triangle where you've got a square in the bottom corner. It could be in the bottom left, it could be in the bottom right, it actually could be in the top. But as long as there's that little square, you know that you're talking about a right angled triangle. So that's very important because if you do not have a right angled triangle, you actually cannot do sine, cos, and tan in this situation. So sine, cos, and tan all works around Pythagoras, and that's where we'll be getting into a little bit further on. What we've got here is that we've got an angle of 25 degrees. So if I look at x, and I'm talking about 25, is it an alternative angle or is it the opposite? Because we know that y is definitely the hypotenuse. The hypotenuse is always opposite the 90-degree angle, which is represented by that square. So if I'm trying to find out x and y, and I've got 7 must be my adjacent, alternative or adjacent, depending on what people call it. So I just call it alternative, generally speaking. It still stands with an A, and that's what really counts. So I know that my hypotenuse is always opposite 90. I know that my opposite is always opposite my angle, and then obviously the adjacent, or what I call the alternative, is the remaining side. So in this case, we start with step 1. We've got SOHCAHTOA or SOHCAHTOA, depending on how you want to say it. It doesn't really matter, it just matters how you spell. We have got our x and y. We actually don't have them. We have 7, but we don't have x or y. So how do we deal with this? Well, let's try with sine, okay? Let's try with sine, because sine is going to give you O over h. But that would be sine 25 is equal to x over y. This is a bit of a difficult situation, because what do you isolate? I think it would have been easier if we'd gone with cos, because you would have had your adjacent over your hypotenuse. Your adjacent is 7, and your hypotenuse is unknown. So you would have said cos of 25 degrees is equal to a, which is 7, over h, which is y, which is unknown. And you would have manipulated your equation, you would have solved, just like we've done over here. So it is kind of important to just take a few seconds, or maybe 10 seconds, to just analyze your drawing and think to yourself, well, maybe I shouldn't use sine. I'm comfortable with using it, but in this situation, it's definitely going to be better to use cos. I mean, in this case, you actually would want to use cos and tan, because tan is O over A, because SOHCAHTOA, you haven't got your opposite, but you've got your adjacent. So you're actually only left with one unknown variable. So what do you think you're going to do here? I mean, as I've discussed this, you need to decide. I mean, is it going to be sine? Nah, more likely not than true. Yeah, so there we go. We're going to use cos and tan. That's what I think. You must also work this out. If it's going too quickly, just take a pause, write the stuff down. But generally speaking, it's good to watch the video properly, come back, you get the basic explanation down, come back and then start doing the problem yourself. And if you struggle, watch the video again. Otherwise, if you get it first time, great. But don't think that's the only way to study. You need to then practice and practice and practice so it becomes ingrained in your head and you actually never forget. So now let's rearrange. We've got sine 25, x over y. We multiply by y on both sides, giving us y sine 25 equals x. What does that give us in the end? Not really much. I mean, it's going to give us a simultaneous equation. But if we went directly with cos and tan, we would have had an answer straight away. I mean, just think about if you had like 7 cos 25. You can put that in your calculator and you can find x or y. It's much easier than doing the sine method. However, we need to show you that sometimes if you're going to take the long route, it's It's going to take you a lot longer than what I've just explained to you. But this is the general case. This is how people make their silly mistakes. People call it silly, but it's actually not really that silly. It's quite simple stuff, actually. But if you understand and practice, you can get easy marks from doing this kind of thing. So we've multiplied on both sides by y to try and cancel out the denominator on the right-hand side. You've got y cos 25, which is equal to 7 now because the y's have cancelled. Now let's do this. Tan 25 is equal to x over 7. 7 times 7, if you've got a denominator, cancels. There we go. So we've got x is equal to 7 tan 25. Now we're starting to talk business. Doesn't that look a little bit better? Now if you look above slightly, you can just see that if you had separated, you divided that cos 25 and divided it, you would have had 7 over cos 25 is equal to y. That would have made a lot more sense than what's currently happening. But alas, if you're not thinking about it, or if you're like a little bit confused, this is the slow and long method to get through it. So let's have a look. Let's use this. I mean, if you're going to do simultaneous, you might as well. You'll sub x. You know what honestly might have happened in this question? It might have said, don't use a calculator. So that could well be what happened. But anyways, it doesn't really matter. Let's sub out sine 25 and tan 25. We end up cancelling. You'll see it becomes like 1 over sec or something to that effect. So tan 25 over sine, what would be? So sine over cos divided by sine would give you, yes, 1 over cos, which would be 1, so that would be 7 sec 25. If you looked at probably, I think, the second or third video in the series, you would have actually seen the reciprocals. So when you've got sine, cos, and tan, the reciprocals are cosec, sec, and cot. So in this case, you'd get 7 sec, because that's going to have a 1 over cos. So yeah, 7 sine 25 over cos 25 times by 1 over sine 25. Yeah, there we go. All right, so we're just jumping ahead. It's always good to just look ahead. Seriously, with trigonometry, make sure to look ahead. Don't just keep on writing without thinking. You need to think ahead. Before you write your step, you can get lost in trig if you're not planning. It's very much a strategic sort of mathematics. Over here, we've got y is equal to 7 over cos 25. Or you can just say 7 sec 25. A lot of schools, a lot of systems don't use sec at this level, so we're going to leave it out. All right, so we found our y. We've actually also kind of found our x. All right, there we go. We've got our x is equal to 7 tan 25. Our y that we found earlier is y is equal to 7 over cos 25. We took a really, really long method to get there, that's for sure. We could have easily just gone, from the start, we could have said, okay, we've got an angle of 25. We could have taken our adjacent side over our hypotenuse and said, well, cos of 25 is adjacent, which is 7 over hypotenuse, which was y. We would then multiply both sides by y and then divide both sides by cos 25. That would then isolate your y, and your y would then be equal to 7 over cos 25. And that's what we've got right over here. It just took us a hell of a lot more steps because we didn't have an initial strategy from the beginning of the question. Now, this is the normal case in trigonometry, is that there's many ways to skin a cat. And if you know the fast way, you'll get through your exams and your tests, and you'll do really, really well. However, if you don't do these sort of fast strategic moves that are kind of like considered legal cheating methods, you will struggle to get through tests. You'll do like 5, 6, 7 steps to get like a 2-mark answer. So you really need to hone your skills. You need to really make sure that you come up with a strategy before you answer a question, so that you can get the likes of when you pull out your x. We could have easily from the beginning gone, okay, instead of taking out the sign and then manipulating and doing, simultaneous equations, you could have just done x is equal to 7 tan 25. That's a way faster method of achieving your end goal. So if you wanted to do that, I think you need to focus on doing that in the future. But otherwise, easy game.